When two neutron stars collide, it's like witnessing cosmic chaos at its most extreme. These stellar remnants, each more massive than our sun but only about 12 miles in diameter, hurtle towards each other at incredible speeds. As they draw closer, their immense gravitational forces distort space-time, creating ripples known as gravitational waves that travel through the universe. The collision itself is a cataclysmic event, releasing an unimaginable amount of energy in the form of gamma-ray bursts, the most energetic electromagnetic events in the universe. These bursts can outshine an entire galaxy for a brief moment, emitting more energy in a few seconds than our sun will in its entire lifetime. The impact of the collision causes the two neutron stars to merge into a single, hyperdense object known as a kilonova. This kilonova is a hot, rapidly expanding cloud of debris that glows with intense heat, producing elements heavier than iron through a process called rapid neutron capture. These elements, including gold, platinum, and uranium, are scattered into space, seeding future generations of stars and planets with the building blocks of life. The aftermath of a neutron-star collision is a cosmic spectacle that astronomers around the world eagerly observe. By studying the light and radiation emitted during and after the collision, scientists can gain valuable insights into the nature of matter, the origins of heavy elements, and the behavior of extreme astrophysical phenomena. In conclusion, when two neutron stars collide, they unleash a maelstrom of energy and create a cosmic crucible where new elements are forged. It's a breathtaking display of the raw power and beauty of the universe, reminding us of the incredible forces at play in the cosmos.